Properties of salts. Salts are the neutralization products formed between the action of acid and base. There are different types of salts known: acidic salts, basic salts, neutral salts, etc. Acidic salts contain replaceable hydrogen atom. Salts of strong electropositive metals are thermally stable. Hydrolysis of salts. Hydrolysis is a reaction in which a salt reacts with water to form a solution which is either acidic or alkaline. In aqueous solution, the water molecules react with active ions of the weak acid or base and form free hydrogen ions or hydroxyl ions. This reaction is called hydrolysis. Salts of strong acid and a weak base. Example, aqueous solution of ammonium chloride. Example, aqueous solution of sodium carbonate. Hydrolysis does not occur in salts formed from strong acids and strong base. Example, NaCl, sodium chloride. In hydrolysis, if the product formed contains a strong acid, example, hydrochloric acid, the solution is acidic and turns blue litmus red. Ammonium chloride reacts with water, giving ammonium hydroxide and hydrochloric acid. NH4Cl, ammonium chloride, reacts with H2O, water, giving NH4OH, ammonium hydroxide, and HCl, hydrochloric acid. In hydrolysis, if the product formed contains a strong base, NaOH, the solution is basic and turns red litmus blue. Na2CO3, sodium carbonate, reacts with 2H2O, water, giving 2NaOH, sodium hydroxide, and H2CO3, carbonic acid. Hydrated salts, water of crystallization. Several salts contain definite amounts of water molecules loosely combined in their structures. This chemically combined water present in the salts accounts for the crystalline nature of the salt. Hence, this water is called water of crystallization. Salts containing water of crystallization are called hydrated salts. Water of crystallization is the definite number of water molecules with which a compound enters into a loose chemical combination as the compound crystallizes out of its solution. In colored hydrated salts, the water of crystallization also accounts for the color of the salt. Thus, if a hydrated salt is heated, it loses its water of crystallization, and the following is observed. The salt loses its crystalline nature and becomes amorphous. Colored salts lose their color and become white. Efflorescence. Certain hydrated crystals, when exposed to the atmosphere at ordinary temperatures, lose their water of crystallization and are transformed into a powder. Such a substance is called efflorescent substance, and the property is called efflorescence. Efflorescence is maximum when the temperatures are high and the atmosphere is dry. Examples of efflorescent crystals: washing soda, Na2CO3 10H2O, sodium carbonate decahydrate, Glauber's salt, Na2SO4 10H2O, sodium sulfate decahydrate, blue vitriol, CuSO4 5H2O, copper sulfate pentahydrate, Epsom salt, MgSO4 7H2O, magnesium sulfate septahydrate. Deliquescence. At ordinary temperatures, Certain water-soluble substances, when exposed to the atmosphere, absorb moisture from the atmospheric air, become moist, lose their crystalline form, and ultimately dissolve in the absorbed water, forming a saturated solution. Such a substance is called a deliquescent substance, and the property is called deliquescence. Deliquescence is maximum when the temperatures are low, the atmosphere is humid. Examples of deliquescent crystals: calcium chloride hexahydrate, CaCl2 6H2O, magnesium chloride hexahydrate, MgCl2 6H2O, ferric chloride FeCl3, sodium hydroxide NaOH, potassium hydroxide KOH, hydrated copper nitrate CuNO3 twice 3H2O. Hygroscopy. At ordinary temperatures, certain substances, when exposed to the atmosphere, absorb moisture from the atmosphere without dissolving in it. Such a substance is called hygroscopic substance, and the property is called hygroscopy. Hygroscopic substances are generally anhydrous solids or liquids. They are used as drying agent for drying gases. Examples of hygroscopic substances: anhydrous calcium chloride CaCl2, concentrated sulfuric acid H2SO4, phosphorus pentoxide P2O5, calcium oxide quicklime CaO, silica gel, alcohol C2H5OH,